Have you ever seen this undamped mass spring system? According to physics, this mass will oscillate sinusoidally. But how do we get this curve? First, from Newton's second law, we obtain the equation of motion. Next, we calculate the roots of the differential equation. After that, the numerical solution. The last will be plotting the solution. Now let us proceed to the first step. From Newton's law, the spring force is minus k times x equals mass times acceleration. Through division by m, we leave the second derivative of x alone. We simplify this into a form where we have the square of angular frequency omega in front of x. To solve this differential equation, we use this function, where c is the amplitude and phi is the initial phase. We need two initial conditions to compute x of t. Here are the initial values of position and velocity that are needed to compute the solution. The value of the spring constant K is 8 Newton per meter, and mass m is 2 kilograms. From them, we obtain the angular frequency omega as 2 radians per second. What are the values of c and phi? To compute phi, first we divide the initial velocity by the initial position. After obtaining the value of tangent phi, we can calculate phi from inverse tangent. Next, we will calculate the amplitude c. The position x at t equals 0 is equal to c times cosine of phi. By invoking the trigonometric identity between cosine and tangent, we can calculate c. It turns out that the amplitude is equal to 2.02. Now it is convenient to write down x of t, and what's left for us is plotting the curve. The plot we are looking for is a simple cosine curve. The mass will oscillate forever because there is no friction at all. The period of the oscillation is equal to 2 pi divided by the angular frequency, which is equal to pi seconds. Meanwhile, the frequency is simply the inverse of the period. Thank you for watching this video. This channel will roll out a sequel about damped oscillation soon, hopefully within a week. Kindly please give us some feedback by commenting below, and it is very kind of you to support us by clicking like and subscribe. Again, thank you, and see you in the next video.